Prime numbers are the building blocks of the mathematical universe. A prime number is a whole number greater than one that is only divisible by 1 in itself. Numbers like 2, 3, 5, 7, and 11 are prime. They possess a fundamental quality: they cannot be broken down into smaller, equal whole numbers. Imagine trying to arrange 7 marbles into equal rows. You'll find that the only way is to place them in a single row or a single column. This indivisibility is what makes prime numbers special. They are the atoms of the arithmetic world, the irreducible components from which all other whole numbers are built. Prime numbers are infinite, stretching out across the number line in a seemingly random pattern. This blend of simplicity and mystery has captivated mathematicians for millennia. Finding the greatest common divisor, or GCD, of two numbers is a fundamental operation in number theory. The GCD is the largest number that divides evenly into both. Euclid, a Greek mathematician, gifted us with an elegant method for finding the GCD, the Euclidean algorithm. This algorithm involves a clever dance of repeated division. We start by dividing the larger number by the smaller one and noting the remainder. Then we replace the larger number with the smaller one and the smaller number with the remainder. We repeat this process until the remainder is 0. The last non-zero remainder is the GCD. This elegant method, devised over 2,000 years ago, remains a cornerstone of computational mathematics. The GCD is far more than just a mathematical curiosity. It plays a pivotal role in various mathematical operations, including simplifying fractions, finding least common multiples, and most importantly for our discussion, cryptography. In its simplest form, the GCD helps us determine if two numbers are relatively prime. Two numbers are relatively prime if their GCD is 1. This property is crucial in cryptography, particularly in public key encryption systems like RSA, where the security relies on the difficulty of factoring the product of two large prime numbers. Section 4. Modular arithmetic, the clock arithmetic. Modular arithmetic is like clock arithmetic. Imagine a clock face with numbers from 1 to 12. If it's 10 o'clock and we add 5 hours, we don't end up at 15 o'clock. Instead, we cycle back around to 3 o'clock. In modular arithmetic, we work with a fixed number called the modulus. We perform arithmetic operations as usual, but we're only interested in the remainder after dividing by the modulus. This concept of wrapping around is central to cryptography. In encryption, modular arithmetic helps scramble information in a way that is difficult to unscramble without the proper key. Section 5. RSA, the gold standard of encryption. RSA, named after its inventors Rivest, Shamir, and Edelman, is a widely used public key encryption system. It relies heavily on prime numbers and modular arithmetic. In RSA, two large prime numbers are chosen and kept secret. These numbers are used to generate public and private keys. The public key, which can be shared openly, is used to encrypt messages. The private key, kept secret, is used to decrypt messages. The security of RSA hinges on the difficulty of factoring the product of two large prime numbers. While multiplying two large primes is relatively easy, factoring their product is computationally very expensive, especially if the primes are very large. Section 6. The importance of large primes. A race against hackers. The security of many cryptographic systems, including RSA, relies on the use of large prime numbers. The larger the prime numbers used, the more difficult it becomes to factor their product and break the encryption. As computing power increases, so does the need for larger prime numbers. Cryptographers are in a constant race against hackers, seeking ever larger primes to stay ahead of the curve. The discovery of new massive prime numbers is a significant event in the world of cryptography. The relentless pursuit of these numerical giants underscores the crucial role prime numbers play in safeguarding our digital lives.